Hello everyone again. In today's video, I'm going to show you how to use the comparison test, okay? The comparison test for convergence, okay? The comparison test for convergence. So as always, okay, before directly going to the problems, let's have some little background knowledge, okay? So suppose uh, the series S sub n, okay, S sub n, and we will have another series called uh, B sub n. Okay, they are positive. Okay, they are positive. Okay, they are positive forms. Okay, they are positive forms. All right. So two things we have to know now. Two things we have to know now. The first one is this. Okay, if right, if the summation, I mean the series B sub n, okay, B sub n is convergent, okay, this is convergent, okay, is convergent, okay, and S sub n is less or equal to B sub n, okay. If the series B sub n is convergent and if the sequence S sub n less or equal to B sub n, okay, if the S sub n is less than B sub n, then the series S sub n is also convergent, okay, also convergent, okay, convergence, right? This is very important point. And then the second one is again if, right, the series B sub n, the series B sub n diverges, or if it is divergent, okay, divergent, all right, one condition. And also if S sub n is greater than or equal to B sub n, okay, then that's of course for all n, then also the series S sub n is also divergent, okay, divergent. So this is very important things. We have to just keep a little bit attention to this one, okay. So all you have to see is now if B sub n is convergent and S sub n is less or equal to B sub n, and then S sub n is also convergent, because at the end of the day we are going to determine what happens to A sub n, okay, the series A sub n, that's the original series, okay. Remember, this is the original series we are talking about. This is the original series. So what will happen to this one, and then what will happen to this A sub n is the main concern. So I want to warn you now something. If you see anything, something different from what's written in here, okay, we cannot say anything. What does that mean? Let's say, for example, if B sub n is convergent and instead of A sub n is less than Bn, if it is B sub n is less than A sub n, we cannot say anything about that, okay? We cannot say anything about it. So just let's focus on these two rules first, okay? First thing first, okay? Now, keep this in mind, and then let's see some examples, okay? Some examples. Let's say, or some exercises, okay? Let's say number one, okay? Let's say number one, all right? We want you to determine this series, okay? This series 4, all right, over 2n cubed plus 3n. What will happen to this one? Does this converge or diverge? Okay, this is our A sub n. Okay, this is our A sub n. The original series is just A sub n. Okay, the original series is A sub n. Now, but in here in the rules, I see B sub n, B sub n. So one can ask where I can get B sub n. Okay, I have only A sub n, but where I can get B sub n. Okay, so that's not difficult. B sub n is derived from A sub n. We're gonna find A sub n, I mean B sub n from this one, okay? So my B sub n is gonna be from itself. But how? All right. So always you have to focus on the dominant factor, okay? Remember, as n approaches to infinity, the 3n is insignificant as compared to 2 to the power of n cube, okay? So 4 over 2 to the power of n cube is gonna be the dominant factor as compared to the whole thing, okay? Because the 3 sub n is just meaningless as compared, it's insignificant as compared to the n cube, okay? Or simply you can if you want, you can just know it simply by omitting this part, by omitting the 3n, okay, by omitting the 3n, because that's not the the main factor, okay, or the dominant factor. So b sub n is going to be 4 over, right, 2n cube, basically without 3n, okay. Look, with 3n is the original a sub n, okay, that's the a sub n, and then b sub n is gonna be from it. We derive it from the original, or from a sub n, so that's gonna be b sub n, because this is, remember, after all, this one is a comparison test, so I'm going to compare two things, okay. I'm to compare two things, okay. Now once I have this one, the other important thing also to know is, when I have my b sub n, or when I extract my b sub n from the a sub n, b sub n is known to be convergent or divergent easily, okay. So this is in our mind, or just most of the time we have to think about this b sub n. B sub n is most of the time known, easily known uh, easily known sequence, because we have the power series and the geometric series. Those are easily known series for convergence and divergence. So that's also another criteria, okay, another thing that I have to consider, okay. Now, let me go now to compare which one is bigger, which one is smaller, or simply I can start also with convergent or divergent. So look at b sub n. B sub n is, I can conclude from this one, b sub n, which is equal to 4 over 2n cubed, is simply convergent. This is convergent. This is convergent. Convergent. All right. This is convergent. How do I know? How do I know if this one is convergent? Well, this is easily known to be convergent because this is a p series. You have to remember something from your background. Okay, p series. This is p series. Okay, p series greater than 4p greater than or equal to 1, because the p value in here is 3. Look at that. Okay, p series is something that looks like n the power of p. Remember that one. Okay, so n the power of p. This is the p series. So based on the p, I can decide. This is just one of the lessons that we have discussed, or we have to discuss in calculus too. So p series, for p series, p greater than or equal to 1 is always converges, and then for less than 1, it diverges. So that means the bn here, I see it has p is equal to 3, which is greater than 1. That's why this is convergent. Okay, so convergent. That means now look, if b sub n is convergent, okay, number one met already, criteria number one. If b sub n is convergent, because b sub n is known, and then by p series, I know that that's convergent. That's not enough, okay? That's not enough to conclude about the whole series a sub n. I have to compare also a sub n is less or equal to b sub n. All right, so let me compare that, okay? A sub n means now a sub n, all right, a sub n blank b sub n. Let me compare these two, okay? Let me compare these two, and then if it is less than, then I can simply conclude that's a convergent. So what is a sub n? A sub n is 4 over 2n cubed plus 3n blank, okay? B sub n is 4 without the 3n to the power of 2n the power of 3. Okay, now look. So simply to decide whether this a sub n is greater than or less than, simply I have to compare the denominator, okay? Because we have the same numerator. So this value here, 2n cubed plus 3n is big number. That's big number as compared to 2n cubed, right? Because I have extra 3n here. So this denominator is bigger than this second denominator. So the same number divided by a huge number, and then the same number by a relatively smaller number, definitely this is less than. 4 divided by big number as compared to n cube is going to be less than. So that means this is equal to a sub n is equal to less than b sub n. So look, a sub n is less than b sub n. At the same time, b sub n is convergent from p series. So generally, hence, or generally now, all right, generally, hence, I'm sorry, hence, okay, the series, okay, the series, all right, 4 over 2n cube plus 3, and also diverges. Okay, this also sorry, converges. This also converges. Okay, this also converges. Okay, this is converges. So simply what I did is I used the first rule. Okay, the first rule, the summation of b sub n, or the series b sub n convergent if that is convergent and a sub n is less than b sub n, and the a sub n, the series a sub n, the original series also converges or it's convergent. So I have two of them. All right, and then I see b sub n is easy to tell it converges because of the p series. Okay, by p series, p greater than 1. So once I know about that, I go to compare them, and then a sub n is less than b sub n, as you can see from here, from the first rule. And then finally, the series, the original series is convergent. Okay, the original series is convergent, right? Okay, let's do the second problem, and then that will be how that what makes clear. Okay, that makes it clear. Okay, so let's see. Number 2 is this question. Okay, number 2 is this question. All right. Let's say 6 the power of n. This one is a sub n. Okay, a sub n is equal to, all right. Let me rewrite this one again. All right, this is my series. The series is given as follows. The series a sub n is equal to the summation of, okay, the summation of 6 the power of n over 5 the power of n minus 1. Okay, all right. So we are going to tell if this converges or diverges. Okay, what will happen to this one? Does this converge? Okay, does this converge or diverge? Okay, does this converge or diverge? Okay, as always, all we have to do is I have to know my a sub n. All right, a sub n is simply 6 the power of n, 5 the power of n minus 1. All right, and where is my bn? Remember, I told you earlier, bn is derived from a sub n by considering the dominant factor, or simply by omitting something that's extra, just -1. I can omit -1 now. So b sub n is going to be 6 the power of n over 5 the power of n. Okay, this is b sub n. All right. All right. All I can just now, I have to just work on the b sub n, because I have to know about that one first, because that's supposed to be, or that's known to be convergent or divergent. So I have to rearrange a little bit here. So this is going to be 6 over 5. I can rewrite this one in this form, the power of n. Okay, because I'm taking it into something known, either to p series or geometric series. Okay, the p series and the geometric series are something that can easily be determined whether converges or diverges. I can just simply remember them than any other series, because other series are a little bit confusing and complicated, but the geometric series and the p series are easy rules. So that's why. Okay, so now if you look at this, this is typical geometric series. This one is geometric series, right? Because this is geometric series. I hope you remember this one. Okay, I hope you remember this one. So the geometric series, now you remember that in geometric series we have a common ratio. Okay, you remember that. I hope the common ratio. All right, the common ratio is now the 6 over 5, which is the absolute value of 6 over 5. All right, all right, which is greater than 1. You remember the rule says that if the absolute value of r is greater than 1, okay, it diverges. Okay, it diverges. Okay, it diverges. All right, the rule says the absolute value of r is greater than 1, it diverges. Okay, so now my r value is 6 over 1, which is 6 over 5. 6 divided by 5 is obviously greater than 1. So that means bn, this bn diverges. Okay, this bn diverges because this bn is typical geometric series in this case, and then with r value greater than 1, so this one diverges. Okay, diverges. Okay, now if bn diverges, I know about bn diverges, but I have to compare again an and bn to conclude the whole. Look, bn diverges. Look at now. The second rule is saying that bn divergent. Okay, now I know about that. Now I have to compare also an and bn. An must be greater than bn. Okay, so an a sub n must be greater than b sub n. Okay, what is a sub n? A sub n is 6 the power of n over 5 n minus 1 blank. B sub n is 6n over 5 the power of n. Look now, the numerators are the same. The numerators are the same, but the denominators are different. So the first denominator, this one is less than this one, because look, this is minus. Okay, some number minus 1. Okay, the same number, 5 the power of n, 5 the power of n. Here I have 5 the power of n, 5 the power of n minus 1. So this denominator is smaller. So this number divided by small number is going to be larger in general. Okay, so that is greater than bn. So a sub n is greater than bn. So that means bn is, okay, this bn is divergent. Okay, this was divergent by p series. And if a sub n is greater than bcn, b sub n, and then the series a sub n also diverges. Okay, also diverges. Okay, also diverges. Therefore, in general, my series, which is equal to 6 the power of n over 5n minus 1, diverges. Okay, diverges. All right, so this is by comparison test. So basically, in comparison test, what we have to do is you have to know your bn. Okay, your bn is always coming from the a sub n. Okay, b sub n is coming from a sub n by the dominant factor, or by just eliminating the extra number, okay, in the denominator. And then just you have to follow these two rules. Okay, these two rules. But as I said again, I want to warn you on this one. If this is not the case, that means, let's say, if bn is convergent, but instead of a sub n is less than bn, if it is a sub n is greater than bn, okay, in convergent, that's another story. So we cannot say anything about that. Okay, so just focus on these two things, and then if anything happens out of this, we will treat that one in another video in different way or in different test. Okay, so I hope you enjoy the video. Just feel free to pause the video at any time and anywhere to understand what exactly is going on. And then I advise you to do more practice on this one. This is for today. Have a nice day.